In section 4, we are doing something very similar to section 3. When we divide fractions, we are really just multiplying by the reciprocal, which really means we're multiplying by flipping the second fraction upside down from where it is right now. We're going to head over again to our flow chart, and we're going to be looking at division this time. So we're going to start where we always start, work our way down, and this time we're going to divide. Dividing takes us into multiplying. Multiplying takes us into simplifying. So we are going to pretty much follow our way down the left side of this page. Again, you'll find though that we're not adding that many new things. It's really simplifying is the hardest part of this whole process. So the first part here, the new part, says change the operation to multiplication and flip or take the reciprocal of the second fraction. Not both fractions, just the second one. Let's try that. Instead of saying 3 halves divided by 8a squared over 7, we are going to have 3 halves times, and then we're going to just flip that fraction, 7 over 8a squared. So all we did is we took this fraction right here, flipped it on its head, and then turned that division sign into multiplication when we rewrote it. So an easy example to think of why something like this would work, it seems like kind of a weird rule, but if you think of something like, what is 10 divided by 2? Well, 10 divided by 2 is 5. But what is 10 times a half, or using different language, what is half of 10? Well, that's 5. So if you take the fraction 10 divided by 2 and rewrite it as 10 divided by 2 over 1, same thing. That is the same as multiplying by that 2 over 1 flipped to 1 over 2 by multiplying by that reciprocal. And so you can see how something like this is actually something we intuitively do already with things like dividing by 2 and taking half of something. They mean the same thing in our head. But when it's weird stuff with a's and x's, it tends to not mentally make as much sense right away. So that's the reason behind it. Anyways, all we've done here is gotten to the point where we just created a multiplication problem. So we're going to continue to wrap these things up the way that we always do when we are doing these problems. And when we're doing multiplication, our flowchart says that we need to multiply the entire top and multiply the entire bottom, multiply straight across to create a single fraction. So let's multiply these, and make this one big fraction. Boom. Now we have done that. So the only thing left to do in this problem is simplify, the part that we've been doing for quite some time now. I see that on the top I have a 3 and a 7. On the bottom I have a 2 and an 8. They're not going to share any factors in common. So in fact, it's actually not worth trying to simplify anything on this problem, and I can just go straight to my simplified answer of 3 times 7 is 21. 2 times 8 is 16, and then an a squared. So this right here would be our simplified answer, and you'll see it doesn't actually reduce at all. Now, we always want to check for our excluded values along the way. You'll see that in this case we have a chunk with a variable in it, the letter there, and because it is its own chunk, there's no plus or minus going on. Setting that equal to 0 will in fact end up with a equaling 0 as our excluded value. So just mark that somewhere in there to know that that will not always work when we use 0. Moving on to a new problem, we have one that's already factored for us. Now, because of the nature of how these are written, there's a lot of stuff on the page. Sometimes we don't want to rewrite all of it. And so what I might do when I do a problem like this is to take the second fraction and rewrite it directly above. So I have an a minus 6 here and an a minus 7 here, and I move them up to the top. I have a minus 7 up here that I put on the bottom, and then a negative a plus 5 here that again I'm going to move to the bottom. And what you will see when you do this is now we can combine this into a single fraction by multiplying, because I've now changed it into a multiplication problem. To multiply, we always multiply the tops, multiply the bottoms, and make it a single fraction that we're going to work with. So we now have a single fraction. We have the tops being multiplied together, the bottoms being multiplied together. As we continue on, what we are looking to do is fully factor everything, and it looks like pretty much everything is factored. The only thing that isn't fully factored is the 8a and the 8a here. But since they're exactly the same and they're one's on top, one's on bottom, we're not going to worry about that because they're actually going to cross out for us nicely. Cross those two out. We also have an a minus 7. And there's a little trick when we see something like this here, where we have a minus 5 and here we have negative a plus 5. That's like saying negative 1 times, flip the sign on that, a, flip the sign on that, negative 5. And so you can replace that with something like this and then say, hey, look, now it does cancel out. That's a little trick that you'll see come up often. We try to avoid it because it's not the focus of what we're working on, but you might see that happen once in a while. Just be aware there's that negative 1 trick that lets you pull out the negative 1 out front so that you can flip the things inside and make the things inside cancel top to bottom. When we do all this reducing, we are left with only a minus 6 and on top, negative 1 on bottom. And so this fraction reduces to a minus 6 over negative 1. And if you wanted to even reduce that farther, you could say divide them each by negative 1, giving you negative a plus 6. So that is another way of writing that that's a little bit cleaner. But that one's kind of a messy one. The excluded values, I skipped over that. Sometimes I like to do that at the end. It's kind of your preference, but you always want to work with the factored form, what those might be. That first one, no plus or minus in there, so a equals 0 would be the excluded value. Next one, what minus 7 equals 0? Well, 7 minus 7 equals 0. And then the third one, negative what plus 5? Negative 5 plus 5. And so the a itself would actually be positive. And those are our excluded values, so it's always good to get in the habit of writing those whenever we simplify something. Final example here, it's not factored. I'm going to go through this one quickly just so you can see the process but not dwell on it too much. I'm going to rewrite this as a multiplication problem since it's a division problem. So I'm going to change that to multiplication. I'm going to rewrite right above x squared plus 3x plus 2 and x squared plus 7x plus 6. I'm just rewriting what I had and flipping the order because when we turn division into multiplication, we flip the second fraction and multiply by the reciprocal. So now it says to wrap parentheses around everything that we have. It's always the safe way to do it. And multiply the tops, the numerators, multiply the denominators, and then turn it into a single fraction. So we now have a single fraction with one giant numerator, one giant denominator. Each of these parts, instead of trying to distribute them out into each other and make a bigger part, we're going to break it down into smaller pieces. So I'm looking for something in common, don't have it. Things that multiply to negative 12 and add to 4. If you take the time to make out a list, you'll find that it's 6 and negative 2, x plus 6 and x minus 2. Again, I tend to get that by making a list and finding the ones that work out. Cross that out after factoring. Over here, we're going to end up with x plus 1 and x plus 2 using the same process. Down here, 2 minus x, we'll just leave it. Since we have an x plus 2 up here, or an x minus 2 up here, and this is a 2 minus x, they're very similar. I'm going to do that little trick we did on the other problem where we take a negative 1 out, and that flips the sign so that it's going to be a positive x and a negative 2 instead of a positive 2 and a negative x. So negative 1 times x minus 2 is going to be that right there. And then this last one, you're going to get x plus 6 and x plus 1 as the two factors of this problem. So a lot of factoring problems all built into one big fraction equation, or fraction expression. We're going to do excluded values next. That's always good to do when you get your factors. So we get an excluded value of 2, of negative 6, and of negative 1. So those are our excluded values. And then finally we're going to cancel anything that's completely identical. See an x minus 2, and x minus 2. See an x plus 6, x plus 6. Only top to bottom. You cannot cancel side to side, left to right. You can only go top to bottom. So let's keep looking for that. An x plus 1 and an x plus 1. Leaving us with only x plus 2 on top and only this negative 1 on bottom. And just like the last one where we had something like that, we can divide each of those by negative 1 and get a final answer, most simplified answer of negative x minus 2, with our excluded values over here of 2, negative 6, and negative 1. Good luck on these.